What is uranium enrichment? And why does this term cause such serious concern among governments around the world? And why is uranium enrichment considered a necessary step before producing a nuclear bomb? Most of the approximately 500 commercial nuclear reactors worldwide require enriched uranium fuel, specifically uranium-235. This fuel is absolutely essential for producing energy or nuclear weapons. Uranium is extracted from underground in the form of a yellow oxide. Before enrichment, this uranium oxide must be converted into a fluoride so it can be processed as a gas at a low temperature. Before I explain what uranium enrichment is, I'll give you a brief introduction. All matter is made up of atoms, and each atom consists of protons, neutrons, and electrons, and a single element can have different numbers of neutrons. These versions are called isotopes. Uranium has two main isotopes: uranium-238, which is not fissile, and uranium-235, which is the one we're interested in because it is fissile. When uranium is extracted from the ground, 99.2% of it is uranium-238, while only 0.72% of it is uranium-235. Uranium-235 is considered the primary element that supports the nuclear fission chain reaction. In this reaction, a single neutron causes the fission of a uranium-235 atom. This process releases energy and new neutrons. These neutrons in turn cause the fission of other atoms, and the process repeats, generating an enormous amount of energy in a nuclear weapon. The goal is to produce this chain reaction within a fraction of a second in order to create a very powerful nuclear explosion. How is uranium enriched? Uranium enrichment means increasing the proportion of uranium-235 and removing uranium-238. This is done using special devices called centrifuges. These centrifuges rely on a scientific fact. Uranium-238 is about 1% heavier than uranium-235. Here, uranium in its gaseous form is introduced into cylinders that spin at speeds ranging from 50,000 to 70,000 revolutions per minute. This speed causes the uranium to separate, with the heavier uranium-238 moving down to the bottom of the device and along the inner walls, leaving the uranium-235 in the center of the centrifuge. It should be noted that this process must be repeated several times to increase the percentage of uranium-235. And we should know that producing a single nuclear bomb requires the operation of about 2,000 centrifuges running around the clock for an entire year. What are the enrichment levels? We say that for civilian nuclear reactors, most civilian reactors use low enriched uranium, which has been enriched to a level ranging from 3 to 5% of uranium-235. This percentage is sufficient to sustain a chain reaction and generate electricity. As for nuclear weapons, to achieve an explosive chain reaction, uranium-235 needs to be enriched to a much higher concentration. Technically, it is possible to make a nuclear weapon with a relatively low enrichment level, about 20% uranium-235, which is known as highly enriched uranium. However, the higher the uranium enrichment, the smaller, lighter, and also more destructive the weapon becomes. Therefore, most countries that possess nuclear weapons tend to enrich uranium to 90%, which is referred to as weapons-grade uranium. According to the International Atomic Energy Agency, Iran, for example, has enriched large quantities of uranium at a level that exceeds 60%. And here, moving from 60% enrichment to 90% is much easier than starting from scratch, because there isn't a large amount of uranium-235 that needs to be removed. This is the main reason why the West considers Iran a significant threat when it comes to nuclear weapons production. In addition, the same centrifuge technology used to produce fuel for civilian reactors can be used to produce highly enriched fuel that can later be used to make an atomic bomb. Finally, don't forget to support us by subscribing to the channel and liking this video. Have a good evening.